Hello everyone. So in today's video we are going to learn what are the types of electrodes and we are going to study Calomel electrode in detail. So in previous session we had seen what is a cell. So for a formation of cell we need electrodes, a electrolytic solution and also a salt bridge. So when we form a cell we can measure the cell potential, which is actually the sum of the potential of the electrodes which we are using. So this electrodes which we use in a cell, they either act as a cathode or anode, and the potential of the complete cell depends upon the potential of the individual electrodes. Means the potential of the complete cell is the sum of the potential of the individual electrodes. So this electrodes which we use in formation of a cell, they are of two types. One is the reference electrode and another is an indicator electrode. So a reference electrode is an electrode whose potential value is known and whose potential value does not change depending upon the electrolyte in which it is dipped. So in simple words, an electrode of known potential is called as a reference electrode. Second is indicator electrode. So the electrode whose potential value will vary depending upon the electrolyte in which it is dipped is called as an indicator electrode. So the purpose behind using reference electrode in a cell is that when you form a cell, we get the potential of the complete cell. We don't get the individual potential of the electrodes, we get the potential of the complete cell. So when we have to find the potential of a electrode, that is the indicator electrode, we often couple it with the reference electrode, because since we know the potential of reference electrode, we can easily subtract it from the cell potential which we get to find the potential of indicator electrode. So you will understand this further in the video with the help of an example. Let's see what are the examples of reference electrodes. So there are again two types of reference electrodes. One is a primary reference electrode. The example is standard hydrogen electrode. And another is a secondary reference electrode. So difference between primary reference electrode and secondary reference electrode is that when while forming a cell, if you are coupling or if you are connecting an indicator electrode with a primary reference electrode, the cell potential which we will get, it will be the potential of the indicator electrode, because standard hydrogen electrode, it is a primary reference electrode whose potential value is 0 volt. So its potential value is 0 volt. So when you connect this primary reference electrode with an indicator electrode, the cell potential which we will get, it will be the sum of this reference electrode plus indicator electrode. And since the potential of this primary reference electrode is 0, so whatever will be the potential of indicator electrode, that would be the cell potential. So therefore it is called as a primary reference electrode, because whenever we use standard hydrogen electrode, also called as SHE, or normal hydrogen electrode NHE, when you couple it with another electrode to form a cell, the cell potential is equal to that potential of that other electrode, which is the indicator electrode, since its potential is 0 volt. So this standard hydrogen electrode is formed by dipping a platinized platinum plate in a solution of hydrochloric acid, 1 molar concentrated solution of hydrochloric acid, and also hydrogen gas at 1 atmospheric pressure is passed through that platinized platinum plate. Second is secondary reference electrode. So in primary reference electrode, when you connect this electrode with an indicator electrode, the cell potential is equal to the potential of indicator electrode because its potential is 0. So in secondary reference electrode, this reference electrode has a potential value which is non-zero. It has some value. We need to subtract this value from the cell potential to get the potential of the indicator electrode. So it is called as a secondary reference electrode. Examples of this are calomel electrode, silver chloride electrode, mercury sulfate electrode, mercuric oxide electrode, glass electrode, quinhydron electrode. Now, we are going to see in detail calomel electrode. So Calomel electrode comes under secondary reference electrode. So it has a non-zero potential value. Now this is the construction of a Calomel electrode. You can see this is a broad tube, glass tube, in which a lower layer is of mercury. Above this mercury, there is a paste of mercurous chloride, a paste of mercury plus mercurous chloride. Hg2Cl2 is mercurous chloride. Above this is a layer of KCl solution. This is the wire, a platinum wire, which can go for connection with the indicator electrode. So this is for external connection. As well as here you can see that this Calomel electrode is having a side arm. So this side arm of Calomel electrode can act as a salt bridge. So we had seen what is a salt bridge in a previous video. You all can go and check what is it. Now this is the construction of Calomel electrode. Now the potential of the secondary reference electrode depends upon the concentration of the KCl solution which is used inside it. So it is a reference electrode, so its potential value will be constant irrespective of the electrolyte in which we are going to dip it. So the potential of this Calomel electrode will depend upon the concentration of the potassium chloride solution used inside it. So those values we will see in the next slide. Now Calomel electrode, when it is coupled or connected with the indicator electrode, it can act as a cathode or anode depending upon the position of that electrode in the electromotive series. Now let's see what will be the reaction if Calomel electrode is used. So this mercurous chloride will get ionized to form mercury ions and chloride ions. And this mercury ions will gain 2 electrons to form Hg. So these are the two reactions. The overall reaction would be Hg2Cl2, mercurous chloride will gain 2 electrons to form twice Hg plus twice Cl minus. So Calomel electrode can act as a cathode or anode, and depending upon it, it can undergo reduction or oxidation. So if this Calomel electrode is acting as a cathode, so this would be the reaction. Mercurous chloride plus 2 electrons to give twice Hg plus 2 Cl minus. If it is acting as an anode, the reaction would be in reverse direction. So these are the reaction of the Calomel electrode. The potential of Calomel electrode, the potential of a single electrode can be calculated by using a Nernst equation, which also we had seen in the previous video. So we will write down the Nernst equation for Calomel electrode. It is E cell is equal to E standard cell, that is the potential of the Calomel electrode at standard conditions, minus 0.0591 log to the base 10 of Cl minus ions. So this 0.0591, it comes from the value of RT by NF. So here we have substituted the value of R, gas constant, temperature, upon F, which is the Faraday's constant, multiplied by N, which is the number of moles of electrons involved. So in this case, the number of moles of electrons involved are 2. Also, there is in that case you will see it is actually Q, it is Ln, which we have connected into log. So when we have to take log in place of Ln, we have also multiplied it with 2.303. So when you put the values, you will get this 0.0591. You can go and check the Nernst equation in the previous video to understand better. Now we have seen that the potential of Calomel electrode depends upon the concentration of the KCl which is used in it. So there are three values of potential. If the potassium chloride solution used in the electrode, if it is saturated, the potential of the electrode would be 0.24 volt. Potassium chloride solution, 1 normal concentration. So the potential would be 0.28 volt. If it is decinormal solution of potassium chloride, that is 0.1 normal, then the potential would be 0.33 volt. So depending upon the concentration of KCl, the potential of the Calomel electrode depends. Representation of Calomel electrode. So it is represented as first mercury Hg, which is the lowest layer in the Calomel electrode. It is in direct contact with mercurous chloride. Direct contact is indicated by a single vertical line. And this mercurous chloride is again in direct contact with KCl. So either you can denote it with dot or a single vertical line. So here it is KCl. And on the concentration of this KCl, the potential of the electrode would depend. So we are assuming it as X normal depending upon the solution used. So that's all for today's session. In next session, we will see glass electrode. So if you like my videos, kindly do like, share and subscribe. Thank you.